This is a video demonstration of how to balance a drive shaft using the VCMM. In this video, we will complete the dual hose clamp drive shaft balance procedure using a 2019 Ranger. We have test driven this vehicle and found that there is a first order vibration originating from the drive shaft at 50 miles an hour. This type of vibration can be corrected with the VCMM drive shaft balance procedure. In order to complete the drive shaft balance procedure, you will need the following items: the VCMM, one accelerometer, phototachometer with mounting base, measuring tape and measuring ruler, reflective tape, and two large hose clamps large enough to fit around the drive shaft. Open the VMS software and click on Drive Shaft Balance. Use this screen to enter vehicle information including drive shaft circumference and axle ratio. You'll need to take a measurement using the ruler supplied in the VCMM Advanced Kit to take the circumference measurements of the drive shaft as shown here. Measure the front and the rear of the shaft and enter the information into the boxes provided. Carefully read the directions on the screen. They will give you step-by-step directions of phototachometer placement and calibration, as well as accelerometer placement. The best place to mount the accelerometer is on the bottom of the rear differential housing. Find a spot on the frame of the vehicle to mount the phototachometer where it will not interfere with the spinning drive shaft. Follow the directions on where to place the reflective tape and how to calibrate the tachometer. Next, you will need to calculate the RPM or frequency of the drive shaft. Here's a step-by-step procedure on how to do that. First, measure the diameter of the tire. In this example, our tire is 29 inches. Go to section 100-04 of the workshop manual. Find the tire speed and frequency chart under the subheading Diagnosis and Testing. Compare the tire diameter with the chart in the workshop manual, and then multiply the axle ratio of the vehicle you are working on. In our example, our tire is 29 inches. The speed when the vibration happens is 50 miles an hour. The RPM of the tire when the vehicle is traveling at 50 miles an hour is 595. Multiply 595 by the axle ratio to calculate drive shaft RPM. 2,219 is the RPM of our drive shaft. Now that we know the speed of our drive shaft, we can enter that information in the box. We want to enter a reading plus or minus 200 RPM of our actual calculation, in this case 2,000 RPM. Now you will do an initial run so the VCMM can get a baseline of the vibration. With the vehicle on the hoist or on jack stands, accelerate to the RPM where the vibration occurs while paying attention to the blue arrow on the computer screen. You may need to shift into a lower gear in order to hold the RPM steady. This is where you will need some patience while trying to maintain a steady throttle. Keep the blue arrow in the green area as much as possible. It is normal to have the arrow jump around. Keep the throttle as steady as possible until the VCMM is able to calculate the vibration. The progress bar at the bottom of the screen will update as data is gathered. Once there is enough data gathered, the screen will move on to the next stage. Enter the weight of the hose clamps you are using to complete the procedure. Most hose clamps weigh between 15 and 20 grams. Since we are using larger size hose clamps, we will enter 20 grams as the weight. You will now need to install one of the hose clamps to the center line of the drive shaft. Either make your own reference mark or use an existing mark already on the shaft. In our example, we use an existing mark. With the hose clamp installed on the drive shaft, you are now ready for your second test run. Accelerate the vehicle to the speed at where the vibration occurs and follow the same procedure as you did the first test run. Keep the blue arrow in the green zone as much as possible while paying attention to the progress bar at the bottom of the screen. Once again, patience is required as the arrow tends to jump around, and will take practice to hold it steady. The VCMM has calculated where to place the hose clamps to reduce the vibration. In our example, the first hose clamp will need to be rotated 218 millimeters away from our reference mark in the direction of rotation of the drive shaft, and the second clamp will need to be installed and placed 54 millimeters away from our reference mark on the drive shaft. Measuring from our reference mark on the drive shaft, We will rotate the first clamp 218 millimeters from our reference mark and the second clamp 54 millimeters away from our reference mark in the direction of the rotation of the drive shaft. With the two hose clamps positioned correctly, one more test run will be done to calculate the effectiveness of the clamps. The VCMM will calculate the vibration one last time. The goal is to reduce the vibration as much as possible with the two hose clamps. These clamps will need to remain on the drive shaft permanently. The final screen will display the results of the procedure. The goal is not to achieve zero, since some driveline vibration will be normal. The goal is to reduce the vibration as much as possible. As you can see, in our example, we were able to significantly reduce the vibration to an acceptable level.